Hello everyone, you're welcome to today's class. So in this video, we continue from where we stopped. We're still on compound dimension and we stopped at speed. But want to conclude speed in this video, and then we also talk about density. So we look at speed. We have talked about speed already, which is distance over time, and we looked at some other things there. But this is another aspect of speed we want to look at. When you have journey with more than one part, we have different parts. Maybe you move from this place, then you take a rest and move to another place. So that's what we want to look at. So when a journey is divided into two or more parts, so of different distances and a different average speed. So the average speed for the whole journey would be that will be derived average speed here would then be equal to total distance covered, total or traveled. So the distance that is covered for the whole part, for the two parts or three parts. So if you move from here to here, spending 25 kilometers, and you move to another place, from that place to another place to 15 kilometers, so the whole distance will then be what? 40 kilometers. That was the distance. Then the time, since then speed is distance over time. So it will now be what? Total time taken to travel the whole journey. So total time taken. So this is what we're going to do. Unlike, not that you're given the average speed for the first part. Maybe you're given the average speed, for example, maybe the average of the first part is 12 kilometers per hour. And the second part is what? 3 kilometers per hour. They now ask you to find the total average speed of the journey. So some will just add 12 plus 3 divided by 2. No. If you do it this way, you'll be wrong. So that's the impression I have to correct in this video. So you have to find the total distance taken to cover the whole journey and the total time taken to cover the whole journey. Then divide them together and get your average speed for the whole journey. So let's look at an example and see how we can solve the problem, right? We have these questions now. A man traveled from Ibadan to Lokoja, a distance of 400 kilometers. A distance of 400 kilometers. So the first 250 kilometers, she spent 4 hours. So the first one is 4 hours, 250 kilometers. And the remaining distance, what will be the remaining distance here? That is subtraction of 400 and 250, that is of 150. She spent 2 hours, 35 minutes. So the question now is, calculate the speed for each part of the journey. So if you calculate the speed when she spent 250 kilometers and when she spent 150 kilometers. Then the last part that calculate the average speed for the whole journey in kilometer per hour and 2 meters per second towards 1 dp. So let's now see how to do this here. So look at it, the question. So the first thing, A, is that we've calculated the journey for, so we start with 250 kilometers, right? Okay, distance, the first part. So the distance here is 250 kilometers. And the time, let me divide this into 2. And the time is what? 4 hours. Right? Then, so the speed here, which is distance, divided by what? Time. So that means the distance, which is 250 kilometers, divided by what? 4. So this will give us 1, that is 2. 4 in 25, that is 6, remainder, that's 24. Remainder 1, that is 10. In 10, that is 2, remainder what? 2. I0, that is 5. So this is 2.5 kilometers per what? Per hour. That's the first part. So the second part of the journey. So the distance is what? That is 400 kilometers minus 250 kilometers. Right. So that gives us 150 what? Kilometers. Then the time. What's the time? So she spent 2 hours 35 minutes. That is 2 hours 35 what? Minutes. Right. So let's now see how to calculate this. So the speed here will then be equal to distance divided by what? Time. You can see that this 35 minutes is in minutes, so we need to convert it to what? To hours. So that means to be what? 2 hours. Then 35 what? 35 over what? 60. So 35 over 60 here will be, that is 2 whole number 35 over what? 60, which we can call 5 here 7, 5 here 12. That's 2 whole number 7 over 12. We can convert this 2 times 12, that is 24. 24 plus 7, that is what? 31 divided by what? 12. So we then have the distance, which is what? 150. This is division line divided by 31 over what? 12. This will give us 150 times 12 over what? 31. So we can then multiply this out and divide. So let's use calculator here. By the time we multiply 150 by 12, we're going to have 1,800 divided by what? 31. So when you divide it, 1,800 divided by 31 will give us 58.064516. So we can approximate about 58 point this one to 1 decimal, that's 1 kilometer per hour. So that is the first part. The second part of the journey. Now the last part now asks us to calculate the average speed for the whole journey. So that doesn't mean that we're going to add 62.5 plus 58.1 divided by 2. This will be wrong. So you have to follow the normal process. So B now will be average speed. Average speed for the whole journey. Average speed for the whole journey. Will then be equal to the total distance is what? 400 kilometers. That's 400 kilometers divided by the total time taken will be what? Here she spent 4 hours and here she spent 2 hours 35 minutes. So that will be 6 hours 35 what? Minutes. Right. So that means 400 divided by, so 6 will be 7 over 12. 7 over 12. That's 7 over 12. So then we can then say 6 times 12. So 6 times 12 plus what? Plus 7. 6 times 12 here. 6, that will be 400 divided by 6 times 12, 72 plus 7. That is 79 over what? Over 12. So then let's continue from this place. So that means we have 400 divided by 79 divided by 12. So that is 400 times 12 over 79. So we calculate this on 400 times 12. 4 times 12, 48. That is 4,800 divided by 79. So let's look at what we're going to have here. So dividing this one will give us 60.759. But don't forget to 1 dp. So final answer will then go 60.8 kilometer per what? Hour. So that is the first part in kilometer per hour. So we now need to look for meter per what? Seconds. Meter per second and see what we're going to get. So that is Roman figure 1. This is for Roman figure 1. Then Roman figure 2 is in meter per second. So you can see that everything is in kilometers. So what we're going to do, we convert this one to kilometers, we also convert this one to what? To seconds. Everything to seconds. So let's see the first part. So converting 400, so that means that how many meters make 1 kilometer? 1000. So 1000 meters equals to 1 kilometers. So that means 400 kilometers now. It will be 400 multiplied by what? 1000. That gives us 400,000 meters, right? So it remains 6 hours 35 minutes. So 6 hours 35 minutes. 6 hours. So how many seconds make 1 hour? So 60 seconds make 1 minute, then 60 minutes make 1 hour. So that means 3,600 seconds equals what? 1 hour. So that means we're going to have 6 hours now. So 6 hours will then equal to 6 times 3,600, right? So that gives what? So this one will give us, let me move this one here. So this is 400,000 meters, right? So this will be 6 times 6, 36. 6 times that's 18, that's 21, then 0, 0. So that's 21,600 seconds. Then the remaining part, which is what? 35 minutes. So 35 minutes now. 35 minutes in seconds. 60 seconds, that will be 35 times what? 60. Am I making sense? So this will give us 6 times 5, 30. 6 times 3, 18. 18 plus 2, that's 21. So put the 0. That's 2,100 seconds. Now, the total seconds now, total time in seconds. Time in seconds now. We then be what? 21,600 seconds plus what? 2,100. So adding the two together, what do we have? So what are we going to have here? Add everything together. This will give us 23,700 seconds. So that is total time. So we now go to our speed. So average speed now. So we see on this one, average speed will then be, the total distance is 400,000 meters divided by the time in seconds, 23,700. So 0 cancels 0, right? Seconds. So we divide this one, give us 16.8776. So approximately, don't forget, in one decimal place would be what? 16.9 meter per second. So that is the average speed of the whole journey. So just the same thing with what we have done. I think this is very clear. So we're now going to move to density, which should be the last part of our compound measure. I hope this is very clear. All right, density now. So in this, we want to look at density. Density, as you have it here, it means density of a substance or an object is the measure of mass per unit volume. So we want to measure the mass of an object, just like this one. This is an object, this small phone. It's this object, we want to measure the density. So we need to get the mass and the volume. So the volume, just like this one, we want to measure the density of this. So density is a measure of what? Of the mass per unit of what? Volume that we have there. That's why I said is the measure of what? Mass per unit of volume. So in other words, density quantify how tightly packed the particles are within a material. So like this one, what we have in this one are liquid, right? Then the materials we have here are tightly packed. So this one we have higher density than this one. Are you with me? So if the materials packed in an object are loosely packed, so the density there will be what? Will be lesser than the one which is what? Tightly what? Packed. So that's why I said that general word density quantifies how tightly packed the particles are within a material. So it is calculated as mass divided by what? Volume. So that's where we're going. So when I ask to calculate density, it means you have to find the mass. You might be given the mass and the volume, then find the density. Sometimes you will only be given mass and some other materials that you can use, another measurements that you can use to find what volume of an object. I believe everybody we know the volume of any object. That is the base area multiplied by the height of the object. So if you have any object, you can get the volume of that object. That is the base area of that object multiplied by its height. We give you the volume of, for example, if it's a prism, if it's a prism, it's easier to calculate the volume of that. Is that clear? If it's also a pyramid, it's also easier to calculate the volume of that. So in that case, let's now look at example on how to apply this formula, right? We have these two examples. The first one is find the density of a material with mass 15 gram and volume 20 centimeter cube. Now, before I move to the question, the unit of measurement of density, so the unit of measurement is either gram per centimeters cube or kilogram per meters cube, either of the two. Exactly. So this one will be in what? Gram per centimeters cube. So to solve this one, so density, the formula, the first one is what? Mass divided by what? Volume. So what is the mass in this question? Gram, 15 gram. So that is 15 gram divided by the volume given is 20 centimeters what? Cube. So calculate this one. 5 here 3, 5 here 4. So that is 3 over 4 gram per centimeters what? Cube. So let's take this one to decimal. That is 0 point here, and that is 30. That gives us 7. Remainder what? That's 28. Remainder 2. That is 5. So that's 0.75 gram per centimeters cube. So this is the density of the object. For the second question, if you look at the second question very well, you notice that we are given the mass, a metal box weighing 2.5 kilograms. So because mass is talking about the weight of the object. So this is a mass, measure 20 centimeters by 25 centimeters by 30 centimeters. Calculate the density of the metal in what? Kilogram per what? Meter cube. So you notice that we're not given volume here, right? Do you see volume in what we have here? We only have the mass, but we have all these measurements. So this measurement means volume, because 20 centimeters by 25 by 30 centimeters is what? Is a volume. So in that case, so density here, which is what? Mass divided by what? Volume. So right, so the mass here, the mass given is what? 12.5 kilogram, right? While the volume, we calculate the volume. So the volume here, so the volume, sorry, I will use that. The volume, so will then be, so that is 20 centimeters multiplied by 25 centimeters multiplied by 30 centimeters. Don't forget, what we are looking for, we're looking for the density in kilogram per meter what? Cube. So this is in centimeters. So we need to convert this one to meters. So that's what we're going to do. And then converting this one to meters, we give us 0.2 meters by 0.25 meters, because how many centimeters make a meter? That's 100. So when you divide this one by 100, when you divide it by 100, you get what? 0.2. Divide this one by 100, you get 0.25. And divide this one by 100, we get what? 0.3. Exactly. So we then multiply this now. We multiply it, that's 0.2 times 0.25 times 0.3. So that gives a 0.015. Right. So we can, from here now, this is going to be meters what? Cube. So our density now will be the mass divided by the volume. Right, so what is the volume? The mass. The mass, which is what? 12.5 kilogram, divided by what? The volume, which is what? 0.015 meters cube. So that gives what? This will give us 12.5 divided by 12.5 divided by 0.015, and that gives 833.3. So this will be kilogram per meter what cube. So that is that on density. So this is where we're going to stop on density today in this video. So if you are new to this channel, kindly subscribe and make sure you put on your notification bell so that anytime we release video like this, you'll be able to benefit from it. So we'll meet in our next video. Bye for now.